All right, let's begin. So electronics part 1 revision. Let's do it. So first of all, let's go to the questions, review questions, page 163. The first question was asking us in an oscilloscope tube, what is the purpose of heater, cathode, anode, and X and Y plates? So first of all, let's define the heater. The heater warms the cathode and trigger the thermionic emission. What was the thermionic emission? Thermionic emission was the when a metal surface reaches a certain amount of temperature, it will release an electron. So this is the thermionic emission. So basically, the heater, if heater wasn't there, we wouldn't see the thermionic emission over there. So heater plays a very important role over there. Second one is the cathode. The electrons are emitted from the cathode. So when electron releases, they are released on cathode. A heater heat the cathode and the electrons escape from the cathode surface. And then they are attracted by anode. So the purpose of the anode, attracting the electrons that are coming from cathode. Okay. And the X plates, when the voltage are applied to the X plates, the electron beams move horizontally. It moves from right to left or the left to right, depends on the shape. And the other one, Y plates, when the voltage are applied to the Y plates, the beam of electrons are going to move up and down. If down part is negative, down plate is negative and up plate is positive, then electrons are going to move from down to up, because electrons are going to be repelled by negative parts and they're going to be attracted by positive plate. If a positive plate located like below and the negative plates located the upper part, then the electrons are going to move downward. Okay, they're going to move downward due to attraction between electrons and positive part of the plate. So second question was asking us explain what it means the time base if the time base of an oscilloscope is set 2 milliseconds per centimeter. Remember, 1 millisecond is 1 times 10 power negative 3 seconds. So what does this mean? It means like the spot, there is going to be a spot on the screen of the cathode ray oscilloscope. So that spot is going to move horizontally 2 centimeters in a time of 1 millisecond. Okay, let me just correct over here. In a time of 1 millisecond. Yeah. So the spot on the screen of the cathode ray oscilloscope moves horizontally 2 centimeters in a time of 1 millisecond. It means this, okay? For number 2, 2 milliseconds per centimeter. Okay? So this is the answer of number 2, page 163. So number 3, there were 3 shapes like this. It were given you. Figure 5.12a shows a reading of 1.5 volt, give the values displayed in DC and D. Normally, there is a like let me just take a pointer over here. Normally, there is a, what do you call it? Here we have okay, it's not perfect, but let's put our coordinate system here and here. So normally, figure 5.12 was showing the spot over here. Okay, spot was here. So that the value of the spot is 1.5 volt. That means for each square over the axis over here, it is going to represent by 1.5 volt. If here is 1.5 volt, for A is over here. For A is going to be 3 volt, okay? For A is going to be 3 volt. For B, what is B? B is over here, so it's going to be 1, 2, 3. 3 times 1.5, it's going to be 4.5 volt for B, okay? Each square represents 1.5 volt. So if it's 3 squares above the axis, it's going to be 3 times 1.5. It's going to be 4.5 volt. Here, this is the down part. Again, it's going to be 1, 2, 3. We're going to count the squares. it doesn't matter whether they are down or up. So the magnitude of the voltage over here again is going to be 4.5 volt for C as well. Okay. So for A is going to be 3 volt because you know there are two squares difference from the axis when you counted 1 and 2. That's why it's going to be 3 volt. Or you can do like this, 2 times 1.5 volt because for one square, the value of the voltage is 1.5. So for two square, you're going to multiply by 2. For 3 square, 1, 2, 3 square, as you see over here. For 3 square, you're going to multiply by 3. Again, here, again, 1, 2, and 3. You're going to multiply by 3 to get the voltage for for B, C, and D. It's going to be 3 volt for B, 4.5 volt for C, and 4.5 volt for D as well. Okay? Any questions so far? All right, let's move on. Let's move on then. Okay. So it's 3 volts, 4 volts, 4.5 volt, 4.5 volts. So number 4 is asking us explain carefully why a cathode ray oscilloscope acts as a voltmeter. First of all, why it acts as a voltmeter? Because the voltages to be examined are connected to the Y place of the cathode ray, and the deflection of the beam corresponds to the voltage. Okay, the voltage, the deflection is very small, so that's why it acts as a voltmeter over there. Okay, this is the first reason. The second one for B, the deflection of the beam produced by the voltage of the cathode ray responds to any change in voltage very quickly because it is produced by a beam of electrons which has a very small mass. Okay, since it has a very small mass, deflection is going to be the cathode ray oscilloscope will give the response to deflection so quickly. Okay, because of the electron beam has a very small mass. Okay, the beam of electron has a very small mass. That's why what you're going to see any change on the cathode ray oscilloscope. Okay, this is the reason. The third one, why current is not drawn over here? Because you know there is not going to be any current because there are not going to be any moving mechanical part. Remember, we said this is a beam of electrons, so the deflection is very small. So that's why there is not going to be any movable part. Okay, there are no moving mechanisms. That's why we are not going to observe any current here. Okay, so why current is not drawn? Because the deflection in electron of beam is like it's very small, and there is no moving mechanical part in this deflection. So there is not going to be any production of current for C. Okay. Again, this is page 163. Questions. Okay. Question number 4. So let's go to the question number 5. Why is the anode of the X-ray tube drawn in figure 5.3 made of copper and with a tungsten tip? The reason, you know, remember that anode gets very hot easily because of what? Because when you heat the heater, the electrons are going to escape from. They are going to escape from cathode to anode, and when they escape, they are going to go with the kinetic energy. So since they have a high speed, they are going to make hotter the anode part. So if anode gets hot, it is if the object doesn't have any resistance to this heat, what's going to happen to the object over there? It's going to melt. So in order to prevent this, we use tungsten tip over there because tungsten, remember, has a very high melting point. Due to this, we use the tungsten tip over there. Okay. So the remainder of the anode is made of a block of copper which conducts heat away. Okay. The rest of the heat conduct away by a block of copper which is made on anode. Okay, this is number 5. So let's move to next question. Number 6. 3 uses of X-rays and precautions are asking you over there. So what are the 3 uses of X-rays? You guys know very well when you go to the hospital, you see the X-ray devices. especially if you have a fracture, or if you break some of your bones, you're going to get an X-ray over there to see what's wrong with your arms or your body. Okay, so we use X-ray in medical, airport security. When you pass the airport security, when you pass those doors, they shows whatever, like if you have any medals, they are going to give signal to the like security over there. So airport security, they use the X-rays to see what's going on in your body. Laboratory, again, they use the X-ray devices to identify rays over there. And astronomy, the people like the astronaut or the people who work in astronomy, they also use the X-ray devices to see what's going on in the space. Okay. What are the some precautions that you have to take against X-rays? X-rays. Remember, X-rays are very dangerous. They ionize radiation. They can cause tumors like cancer or sterility in your body. So to keep this to a minimum, there should be adequate lead shielding. Why lead shielding? Because lead is a very good metal which absorbs X-rays. Okay, that's why when you use a good lead shielding, this is going to protect you if you work in an X-ray on an X-ray device. Okay, the operators also should not get too close to X-ray devices, because when they get closer to the X-ray devices, what's going to happen? They're going to get due to radiation, they're going to get the X-ray devices in their bodies. So this is going to affect their bodies negatively, and they can get tumors easily if they do this too much. So people who works in X-ray devices, they generally work in a hospital, and for them, they have to work maximum 5 hours in a day. If they work more than 5 hours in a day, after some time, this is going to cause a big health problem for them. So they have to, like, if you guys, like, in the future, if you want to work, like, in such kind of place, you should be aware of that. You shouldn't work more than 5 hours, okay, if you are working on X-rays. So this was the first part of the questions from page 163. Any questions so far? You guys have any questions? If you have, just raise your hands. Okay. If you don't have it, we are gonna move on to the second part of the questions. So let's go to the second part of the questions then, which is page 106. So the first question, explain why a semiconductor can conduct at all. So first of all, let's define the insulators and conductors. Then we are going to go over to the semiconductors. Remember, insulators, like, they don't have any bond between upper and lower level of the electrons. So that's why they cannot conduct anything at all. Okay. On the other hand, we can give an example for the insulator, like a glass. A glass, when you like connect a glass to a circuit, it is not going to conduct anything. It is not going to give you anything, right? So because it's an insulator, okay. On the other hand, when we come to the conductors, they have a very strong bond between upper and lower of the electrons. Okay, they have a very strong bond. For example, metals. When you put metals inside of a circuit, what's gonna happen? If there is current flowing through that circuit, that metal will conduct the electricity over there. Okay, and between these two, there is semiconductor. As from the name, as you can remember, the semiconductor. So semiconductors, they have a not strong or weak bond. They are in the middle. So when you hit the semiconductors, they're going to conduct electricity, or they're going to have the conductivity when you hit them, because electrons are going to release from the surface of from the lower band of the like semiconductor, and they're going to reach the upper band. When they reach the upper band, this is going to cause the conductivity. This is this is the definition for conductor, insulator, and semiconductor. So let's answer our question: why a semiconductor can't conduct at all? Because the structure of the semiconductor contains both freely moving electrons and holes. Holes represent by positive, okay? Remember, normally protons do not move inside of an atom, right? But here for semiconductors, the charge carriers are electrons and holes, okay? holes positively charged. Okay, they are positive. So if a voltage applied to a semiconductor, it will conduct because electrons move in one direction, and on the other direction, we are going to see that holes are going to move. Okay, electrons move in one direction, holes other within the materials. So that means they have two charge carriers. That's why they conduct. Okay. And normally, how conduction happens, the electron carries the conduction part, and they are responsible for conduction. But here, for semiconductor, holes and electrons are responsible for the conduction. Okay, that's why semiconductor can conduct easily. This is the answer of first question. Okay, so let's move on to second question. The second question: why a semiconductor conducts better when it's hot? Remember, when you heat as like anything, when you heat it, what's gonna happen? The surface of the material, there are electrons. So due to thermionic emission, the electrons are going to escape from the surface of the metal, and when they escape, this is going to cause a better conduction. The same thing is applicable for the semiconductors. At higher temperature, more electrons in the semiconductor will have enough energy to break free. So they are going to have enough energy to break free, to go to reach whatever they wanted. So the material will conduct better. Okay. When you heat all materials except insulators, conductors, and semiconductors, when you heat them, you're going to increase their conductivity. Okay. If you heat the insulators, what's going to happen to insulators? You can try. They're going to melt because they don't have high melting point. So when you heat them, they're going to just melt. For example, take a glass. When you heat the glass, before glass reach the conductivity level, it's going to melt. Okay, that's why like they call it insulators. But semiconductors like silicon. Do you guys know what is a silicon? Wait, let me show you a silicon. I'll show you at the end of the lesson. I'll show you a silicon so you can see. Okay. So this is the answer of second question. Any questions so far? You guys have? No. All right, let's move on then. Yes, Sidona, go ahead. I think Sidona raised.
Page 163, question number 2.
Question number 2. Let's go back then. Wait, let me go back.
Okay.
We went over it actually. Question number 2. Here, 2 millisecond per centimeter. What does it mean? 2 millisecond per centimeter. So remember, first of all, 1 millisecond means like 0.01 or 1 times 10 power negative 3 seconds. So it means like the spot on the screen of cut-ray oscilloscope moves 2 centimeter in 1 millisecond. Okay, 2 centimeter in a time of 1 millisecond. It means this. Okay.
Okay.
This is the answer. 2 centimeter in 1 millisecond it moves. Okay. So number 3, 4, I think you just reached that part. So let's move on. Okay, number 2 and number 3. The last question, I think it's from page 166. Explain what we mean by a positive hole in a silicon crystal. I'm going to explain this from chemistry. You guys, you know, when electrons like when electrons leave an atom, what happens to the atom? The atom is going to be positively charged, right? When an electron leaves an atom, so it's going to create a hole. So the same thing here. In the lattice of the silicon, so we don't have time. In the lattice of the silicon crystal, an electron can be shaken free of one silicon atom. So when an electron leaves an atom in this way, the atom becomes positively charged. Okay. So the positive charge carrier is called hole over here. Hole. Okay. Hole is a positively charged carrier here in semiconductors. We don't have charge carriers in the other atoms, like in metals, for example. In conductor, you don't have it, but in semiconductors, you have holes. We have holes and electrons. Holes are positive charge. Electrons are negative charge carriers. Okay, don't forget that. Any questions about this? So since an electron leaves the atom, it's going to the atom will be positively charged, and we call this positive charge hole. Okay. Any questions? This is the last question, by the way. I think, yeah, this is the last question. Let me see. Yeah, this is the last question. If you don't have any questions, you can like ask previous question as well if you want it. About previous questions. If you don't have it, I'm going to end the video. We have just only 7-8 minutes, so we can spend it too. Again, let me just stop it. Wait up, just